Welcome back for the next session. Now I request Hitendra Sharma sir to take over the session.
Uh, okay, very good morning, everyone. This is Dr. Hitendra Sharma. Am I audible to proceed further?
Yes, sir. Yes, sir. Yes, sir. It's audible, sir. You can proceed.
Right.
Yeah.
Let me share my screen as well. Okay. I hope my screen is now properly shared and it is visible, right?
Yes, sir. Yes, sir.
So once again, I welcome all the participants of this FDP. And from my end, this is the second lecture. In the first lecture, I could cover the basic mathematical skills required for data science as well as data analytics. And now this second part of my lecture is on data visualization, but it is not possible to complete the entire visualization topic in the given small period of time, but I will try my best to give you to introduce whatever the easy ways of doing the data visualization. Okay, so this introduction is already done by the organizers. Thanks for the brief introduction in the first half. So coming to the current context, the data visualization part, most of us know that instead of verbal communication, it will be more effective if you show some pictures. So pictures speaks many things than words. So data visualization is a way to show a complex data in a form that is graphical and easy to understand. See, one interesting point I should emphasize here that in the recent years, there are plenty of opportunities, and still the number of opportunities are growing up constantly in this particular area, data visualization and analytics part. So maybe as we belong to teacher community, let us give this kind of opportunities to our students as well, so that they will definitely have bright future in data visualization and analytics. So analytics data visualization plays a vital role for exploratory data analysis. As I mentioned just now, this visualization will communicate data very clearly without any ambiguity. We can share unbiased representations of the data, use the pictures, whatever the graphics we draw, they can be used to support recommendations to different stakeholders like business people, okay, some CEO of a company to take a decision on their employee retention, okay, and based on the uh, sales of a particular item, how to promote the sales, what could be the proper recommender technique to enhance the sales of a particular item. So lot many things will come into this point. So let us all recall that the saying that a picture is worth 1,000 words. Visualization provides a powerful way to communicate a data-driven findings. What is data-driven findings? That is what I was just saying. Data-driven findings are, for example, you have large amounts of data of transactional database, and after your proper analysis, you could find that there is some relationship between item 1 and item 2. If item 1 and item 2 put together, then definitely they will increase the sales. Such kind of findings can be identified by using this data visualization part. Okay. And in some cases, the visualization is so convincing that no follow-up analysis is required. No further analysis is required if you do the proper visualization. So the pictures will definitely enable the administrators to understand what could be the further action to be taken place, provided the analysis and pictorial representation is properly given. So the growing availability of informative data sets and software tools has led to increased reliance on data visualization across many industries, academia, and government. See, even the government, I should give one simple example that how government will use the graphics data visualization for decision making. For example, the recent attacks by Tufan. So recently, our Prime Minister Modi has already visited completed an aerial survey. So is it that only the Prime Minister is watching this real scenario just by observing that he is trying to take the decisions? Absolutely no. He is taking the help of the data provided by ISRO. What could be these pictures will help the team to estimate the disaster, what happened, and what could be the remedial action, and what probably at what rate the floods will affect, to what extent. So these data will be given in the pictorial form, because the Prime Minister or any person, administrator in such in that context, so they are not data scientists. They are administrators. So they should know the data in the pictorial form if it is properly represented. So this is what the role of data analytics as well as data visualization. And since long, this data visualization has been playing a vital role in decision making in the both in academia, industry, as well as government. So I feel that it would be good if I provide you what are the online data visualization websites for your further study as well, because as I mentioned, this is a beginner's tutorial one can consider, and the further studies to be very much important to make yourself as complete professional in data visualization. So these are some online data visualization websites that I could observe from various reliable sources of information. Okay, and coming to softwares, these are the primary list of softwares I could get from reliable sources of information. And the first one which is listed in the software, that is Tableau, which is very much easy, and as per the data available, it is the popular software which is being widely used across the globe for data visualization as well as business analytics. And the other softwares are also listed. MATLAB is one among them, but it is proprietary, we have to purchase. And Matplotlib, that is one thing which is freely available, but one has to be familiar with Python programming in order to use this Matplotlib for effective data visualization. Of course, R programming is there, which is freeware, for anybody to use. It needs some sort of practice of working with commands, right? Our commands. So that is what the takeaway from this slide. So Tableau. So in this lecture, I would like to provide you some sort of introduction and how to use Matplotlib for that data visualization, and towards the end I would like to provide you some sort of introduction of Tableau as well, so that because Tableau one version is freely available for students as well as professionals as well. So that I would like to introduce for benefit of larger audience here, larger participants here. And these are the data sources which are freely available to get your data for analysis, to do some experimentation on your data. So Google Public Data Explorer is there, and I have provided proper links. So one can take it forward from this slide, right? And data is also available from various sources. And this is one thing. Machine learning databases are also available. So the third link is given to access those files. And before we go to the details of visualization, one should know what are the general modes of data visualization. See, I am now using one way of visualization. I am conveying my data to reach a large group of audience, right? Wherein the graphics what I am showing now, you are able to watch, but you are unable to change the graphic from your end, right? So this is what we are doing. If you see the last row, this is the last row. So this is what exactly we are doing. This is presentation visualization. Users only observe, and from my end graphics are already pre-computed. That means whatever the plots, whatever the boxes, drawings, tables, whatever I draw, so this is all pre-computed from my end, and it is rendered from my end, right? And target audience, my colleagues, mass audience, are able to observe the graphics whatever being rendered, right? And this is one way of using visualization. The other way is interactive visualization. See, in this interactive visualization, so we can produce some real-time graphics which are like bar charts and pie charts, but whenever it is made public, then people who are seeing that, they will also be able to change the graphic as per their own analysis, as per their own requirements. Okay, for example, assume that we have provided a dashboard with all sorts of graphics on COVID pandemic analytics. Okay, so on this platform, let us suppose that we are very much interested to see the COVID positive growth rate only in some area in Andhra Pradesh, like Anantapur. Then user will be, if user has this kind of opportunity to see the data and see the graph of, let us say, line chart regarding the growth rate of positive COVID patients, so that if the user also have this kind of opportunity to do this analytics using the graphic provided by you, then this kind of interaction, this kind of visualization is termed as interactive visualization. That is the first row it's saying. So user controls everything, including the data set. They can change the data set, they can alter something, they can do the visualization using some portion of data, okay, etc. That kind of scope is given for the user. So this is interactive visualization, okay. And the third one is interactive storytelling, wherein it is also similar to your interactive visualization. User can filter or inspect details of present data sets. User can pose questions, get the answers as per their own analytical requirements, right? It is also like interactive visualization. It can be done in real time from both ends, okay? And preferably, it is, for example, is a medium for this interactive storytelling kind of thing is internet or kiosk is required. So as I mentioned, we are majority times will be using this, and in some real-time scenarios, dashboards, many professionals are using this interactive visualization as well. Okay, so going forward to become a complete a professional in data visualization, one should be proficient with all these kinds of platforms, visualization modes. Sorry. So as our present tutorial is focusing on presentation visualization, we'll be taking some sort of data and we compute some graphics, okay, and that will be shared to that will be presented. Before doing that, we should know what is data, what kind of graphics we can produce on the data, what is the ultimate use of producing the graphics, what is the ultimate use of producing this data, using this data visualization. The aim is that whatever the graphic you produce, whatever the visualization, whatever the chart, whatever the picture you produce, that should speak something. That means a meaningful inference should be derived from your picture. That is what it is. And to do that, one should know which picture will be suitable for what kind of inference. Okay, so that requires some sort of understanding before we straight away go to producing some charts, bars, etc. It requires some understanding on what kind of charts available, which chart is suitable for what kind of purpose, okay, and what kind of data one kind of chart or plot is meaningful, okay, and how to derive some inference from that. What is the data useful for that? What kind of data, and how do we use the data? What kind of statistics we can analyze? So that is all very much essential before we write some graphs, charts, etc. So that is the reason why we have to look at some basics of statistics. So the statistics is around us every day. For example, it is the following questions are most frequent questions among us in day-to-day life. Will it rain? Will it be raining tomorrow? This is an obvious question, right? In rainy season, many farmers will be exchanging these kind of questions. Do the flat rates become more expensive in 2024? Who is the highest paid hero in Telugu film industry? What is the starting salary of a business analyst? Which one pays more salary, data scientist or data web developer? These are some obvious questions that will be frequently floating in our discussion. Are the villagers most likely to relocate their nearby cities because of pandemic or some circumstances? Villagers may be moving to nearby cities. Are the villagers most likely? What is the mean? This is also more frequent question that will be occurring. Can we get minimum quotation for interior design for those who are working daily on this kind of business? Who is the fastest bowler? Because IPLs are going on. This is the interesting question, obviously. Okay, let us see what kind of statistics is there inherently in each of these questions. Will it be raining tomorrow? In this question, we are finding the likelihood, that means the chance, that means the likelihood of getting rain tomorrow. We are estimating the likelihood there. We are calculating the likelihood there. Second one, do the flat rates become more expensive in 2024? This is also that we are trying to see, trying to calculate the likelihood. The third one, in identifying the highest paid hero, we are looking at maximum, right? And highest paid salary, the best salary, or starting salary. Starting salary reflects the minimum. We are looking at minimum. How many 10+2 students are registering for engineering? That means we are looking in terms of, we are trying to understand in terms of percentage of the entire population. After 10+2, how many such students are registering these engineering programs? So this is in terms of percentage we are trying to understand. Are the villages most likely? This is also trying to look at the likelihood part. Can we get best quotation for interior design? Best quotation means we are looking at minimum. What is the average salary? It means we are trying to find the maximum average, that is the mean. Okay, so the statistics are everywhere in our day-to-day life. Before doing this analytics, we should also know the data types. So the categorical data types, because I believe that the participants of this workshop, they are familiar with this terminology. Okay, that is why I will just quickly wrap up the concept of data types. Majorly, categorical and numerical variables are the two data types. In categorical, okay, like example, gender, male, female, regions of the states, etc. Categorical variables may also be divided into ordinals or non-ordinals. Ordinals means the values of those variables do follow some sort of ordering or hierarchy. For example, spiciness is the variable, okay, can be categorized, there is some hierarchy inherently, that is mild, medium, or hard. Okay, so even if they are not numbers, they do have some internal hierarchy. That is what that kind of variables are said to be ordinal variables. And non-ordinal variables means they do not follow any inherent hierarchy there. And another category of data type apart from categorical is numerical. In numerical data, for example, population size, right, have a numeric value, land rates, heights of persons, etc. Again, in numerics, we do have some categorization like discrete and continuous. Discrete means values with preferably rounded numbers. For example, counts of such population, okay, and number of vehicles that are seized every day because of violation of traffic rules, etc. So those comes under examples of what? Discrete values. And numeric continuous variables, on the other hand, are those that can take any value such as heights, okay, with some fraction as well. It is all such, they are all real numbers, okay, with enough precision. For example, a pair of twins may be 68.12 inches, and some other examples like heights also we can take. Distance, preferably one good example, right, to 12.2 kilometers away from 1.1 city to another city, something like that. So there are all examples for what? Continuous variables. So note that discrete numeric data can also be sometimes be ordinal, okay, in different contexts. Okay, now it is one precise way of understanding the different types of data. Discrete, continuous constitute the columns of this table, and ordinal, okay, non-ordinal, both in discrete as well as continuous. So ordered means the values are comparable, unordered means values cannot be compared. Then discrete, preferably rounded integers. Continuous values between integers, including fractions with some precision. Okay, so ordinal variables, for example, small size, medium size, L, XL sizes, etc. There is some order. Okay, they may be quantitative as well. Counts 1, 2, 3. There is some order here. And continuous continuous variables which are ordered, example is altitude, temperature, etc. There is some order. Okay, 52 degrees temperature is less than 72 degrees temperature, right? And similarly altitudes as well. And coming to discrete unordered, okay, unordered means there is no ordering, there is no comparison at all. For example, shapes like triangle, okay, circle and square, and these are examples of discrete. And categorical, their very good example is nationality. And coming to continuous unordered variables like directions, like north east, okay, towards the side and etc. That means east west directions and hues. There are all examples for continuous unordered. Now, after understanding in brief what is this data type, and we should now need to understand an important concept of statistics, that is the 5-point summary. So a 5-point summary is especially useful in descriptive analysis or during the primary investigation of a large data set. Usually a data scientist will be more interested to produce what this descriptive analysis. So what this 5-point summary is speaking about? A 5-point summary consists of 5 values as it is mentioned in the name itself. Okay, there are 5 values in this 5-point summary. What are those 5 values? The values, the most extreme values, that means minimum, maximum, right? These are the 2 values. Lower, upper quartiles, lower and upper quartiles, and median. So these are the 5 values that constitutes the 5-point summary. Okay, maximum, minimum, lower, upper, as well as median. So these values are presented together and ordered in an ordered form, lowest to highest, minimum value first, then lower quartile, that means usually denoted by Q1, median value next, that is Q2, upper quartile denoted by Q3, and maximum value. So in this order we'll usually put this to get the 5-point summary. So what is the first one? The minimum value. Here in the diagram one can easily understand. Okay, this is one way to pictorially represent using the graphic called box plot, right? It will give the information about this 5-point summary. So minimum is there in the bottom, this is the first one, and then first quartile, that is the lower quartile, Q1, third quartile, the second one is median, right? After first minimum, first quartile, then median, then third quartile, Q3, and maximum, right? So this is minimum, this is first quartile, this is median, this is the third quartile, and this is maximum. Okay, then let us understand the quartiles with some example. Given the example data is like this, it has some values. Assume that these are some number of items sold at frequent on some dates, let us say. So the data is like this: 6, 47, 49, 15, 43, 41, 7, 39, 43, 41, etc. Yes. Okay. Before we do this, identify these values of median, upper quartile, and lower quartile. We should sort the data in increasing order. Okay. So after proper ordering, that means in the increasing order, the data looks like this. So then median is the one which is in the middle of the data. Okay. So 6, 7, 3, 4, 5, 6, 7, 8, 9, 10, 11 values are there. So the median becomes the central element after ordering this in the increasing order, after writing the data in the increasing order. So here in this example, that becomes what? 41. That is the median. And then upper triangle, upper quartile, sorry, upper quartile and lower quartile. So this is the median of what? The lower quartile denoted by Q1 is the value of the middle of the first set. What is the first set? Before this median, the first set is what? 6, 7, 15, 36, 39. There are 5 elements. So the lower quartile Q1 is the value of the middle of the first set, where there is 25% of the values are smaller than Q1 and 75% are larger. Okay. We do this. Upper quartile denoted by Q3 is the value of the middle of the second set, where 75% of the values are smaller than Q3 and 25% are larger. Okay. So as this example is very clear and simple. So the lower quartile is 15, and the Q3 value, that is the upper quartile, if you look at after median, this is the rest of the part, right? And in this, if you see this 43, it is clearly at a point where 75% of the data falls less than this and 25% of the data falls above this. So this is the point which will be now become what? Q3 as per the definition. Okay. So it will be easy to calculate because this is the very simple data. The numbers are very easy to extract. Okay. And I'm now trying to give you another example where you can do some math here to understand how to calculate these quartiles. Okay. For example, 12 months data is given regarding sales of a particular person. That means, let us say, for example, Mr. Sham is working at a computer store. So her supervisor asked him to keep the records of the number of sales he made in each month. There are 12 months. So the following data is the set, is the list of his sales for the last 12 months. Okay, and this is not ordered. So in order to calculate the median, range, upper and lower quartiles as well as the interquartile range. So I forgot to mention this word interquartile range, right? Sorry, in the previous slides, what is this? Okay. So I'm sorry that I forgot to mention this important word, that is IQR, that is interquartile range, is the difference between Q3 and Q1. Okay, the third quartile and first quartile, that is the interquartile range, Q3 minus Q1. So let us work on this data to get these values. Okay, this is the data given after ordering, after doing this, after sorting this in ascending order. The data values are like this, and then finding the median. So there are 12 values. So median means the central element. So median becomes what? Take the central two elements, 24 and 28, as the number of elements are even in number. So the central becomes the average of these two central values. Okay, 24 plus 28 divided by 2, the median becomes 26. And now the range. What is the range actually? It is also another important one. The range is the difference between highest and lowest values, the minimum value and maximum value. The difference between the highest and lowest values, that becomes the range. That is the 56 in this example. Maximum is 57, minimum is 1, so that becomes 56. A lower quartile Q1 is the value of middle of value of middle of the first half of Q1. So this is nothing but the median of the first half. Median of the first half. What is the first half? So it includes the values 1, 11, 15, 19, 20 and 24. This is the first half. Okay, this is the second half. And because it means the 50% of the data falls here, 50% of the falls here, we are looking at the point where the 25% of the data falls on the left hand, 75% data falls on the right. That is what the Q1. Okay, so in this example, we will find the value in such a way, finding the middle one, that means what is the median of the first half. Median of the first half, because there are 6 elements, again find the median of the first half. It is nothing but the average between average of the two values 15 and 19. So this is the median of the first half. So this value 17 is saying that 25% of the data falls less than 17 and 75% of the data falls more than this value 17. So that by definition it becomes what? Q1, our lower quartile. And then similarly upper quartile you can compute in the same way, finding the median of the remaining part of the data. Okay, so in this example there are 6 elements on the right hand side, and now the median of the second half of the list is the average of the two values 37 and 47, so that becomes 42. So your Q3 value, that means the third quartile value, becomes 42. So 42. This is your Q3. And then interquartile range. As I mentioned, this is the difference between Q3 and Q1. 42 minus 17. That becomes the interquartile range. Okay. Now, reasonably good exercise has been done, I believe, to understand, to demonstrate the 5-point summary. Okay. Moving forward, we are trying to understand now what kinds of charts, what kind of graphics are available and which is good for what purpose. Okay, I'm trying to provide you some picture here. This is the extreme presentation method developed by some professor Abela. Okay, and this picture is the comprehensive one to get the understanding, get the view of what charts are available for what purpose. So the most important thing to realize is that the type of visualization we use, that depends on the type of the variable we are trying to analyze. So type of the variable we are trying to analyze matters in selection of the visualization we have to use. For example, in order to visualize categorical variables like gender and color, we have to go with one kind of graphic. To visualize continuous variables like age and income, we will be most of the times taking the help of line charts. Okay, so the graphic, the visualization, it depends on the data type as well. In one case, we may be using bar charts like sales of particular items which are numeric. Okay, in other case we'll be required to use some scatter plots. Okay, so going forward we'll be understanding what is this scatter plot that reflects the relationship between two variables. Okay, so this is one picture which will help us. So I'm trying to extract each component. Visualization by on few categorical values. So to compare items with a few categories, if you have items we need to compare with few categories, we have to use bar charts or column charts like this. Okay, for example, okay, rentals of particular region, because going forward we'll be using some example data. Okay, or sales of particular item in each year. Okay, comparing few items like sales of cars and sales of two-wheelers in each year on x-axis. Okay, so in that case we will be using these kind of categories. So to compare items with few categories, we'll be using bar charts or column charts. If many categories are there, we have to use table or table with embedded charts. So this we may not show in our example data, but definitely we'll be trying to see the bar charts and column charts. Then the second one is, if you want to compare behavior over time, and if you have the time periods running into several months. Example, sales of a particular item. Okay, on x-axis, assume that we have taken the timeline. Okay, so if you want to depict, if you want to explain, illustrate behavior of a particular variable over time, okay, for example, on x-axis with respect to time, this is sales of a particular stock, okay, comparing the sales of another stock in a stock market analysis. Okay, line chart, how the number of positive cases, COVID positive cases are increasing with respect to time. Okay, so with respect to time, this is an example of non-cyclic data. So comparing many categories, number of immigrants from one country. Okay, let us say the first one is showing number of immigrants from India, number of immigrants from China, number of immigrants from another country, etc., or a period of time. Okay, so this are the some examples wherein if you want to compare the behavior of a particular thing over time, we will be using this line charts, column charts. Okay, then if we're trying to depict relationship between two variables, two continuous variables, then your choice should be a scatter plot. Okay, we'll be giving some examples. What is the age of a person and height? So age and height are the two continuous variables. Okay, age and height are the two variables. Age is taken on x-axis, height is taken on y-axis. Then to understand the relationship between these two variables, we'll be using a scatter plot. And bubble chart is less frequently used when compared to scatter plots, as per my my view. But scatter plot, but these bubble charts also will be important in order to depict two variables on x-y axis, and the third variable will be depicted by the size of this circle. And another one type of graphic is that when to use the column histograms. This is the histogram concept. Okay, 3D area charts, etc. If we are interested in depicting the distribution of data sets, this is another interesting thing, because most frequently data scientists should be able to visualize the distribution of the data. So in such case, we can use histogram in order to depict the distribution of the data set. Okay, then and we will be also using line histograms. If there are few data points are there in the data, to depict the distribution, we'll be taking the help of histograms. On the other hand, if the data points are more, then we will be taking the help of line histograms to depict that information. Okay, as I mentioned, if there are two variables for comparison, we'll be using scatter plots, and in case of three variables, we'll be using 3D area charts. So the distribution could also be shown through this scatter plots. And coming to this one, to this slide, when do we use pie charts and other models like waterfall chart model, picture, graphic, okay, and stacked column charts? See, if we would like to show the comparison, if you like to show the composition, then if it is static data, for example, out of the population, how many are COVID positive patients? Let us say currently there are 60% COVID positive patients, okay, and 40% are COVID negative patients. So we are trying to depict the composition. Okay, of the static data. Assume that the data will not change, then we'll be using pie chart to represent that. Okay, and coming to the last one is, when do we use stacked column charts, stacked area charts? So the stacked area charts, if you are showing if you are showing the composition that changes over time. So this is where the composition do not change over time. And here, if we want to depict the composition which is changing over time for few periods, you can use this stacked columns, maybe stacked bar charts or stacked area charts. So if you have several periods, you can use the stacked area charts for that. Okay, so in the demonstration, we'll see how we can use this stacked area chart as well as stacked column chart. Okay, so we are slowly moving on to the tools for visualization. So in the session so far, I discussed why data visualization is so important and what are the online platforms available, what are the softwares, openware as well as paid proprietary versions which are available, and I have also given you some links to get some data for your data analysis as well as visualization. Then we introduced some basic concepts of statistics, in particular the 5-point summary, okay, which includes minimum, median, quartiles, and maximum element. Okay, the 5-point summary includes the minimum element in particular order, minimum, then Q1, then median, then Q3, and then finally maximum element. So this is the 5-point summary to have a descriptive statistic of the given data. And we have also explained, we have also verified how to do this, how to calculate this Q1 and Q3 as well as interquartile range, that is IQR, with the help of some data. Then we moved on to understand what kind of different kinds of plots or graphics available in data visualization, and in what kind of scenario, for what purpose we have to use which kind of data. That is briefly explained so far. So then we are moving on to the tools. The tools for visualization. So as I mentioned in my tutorial talk, this session, I am trying to focus on Matplotlib, Tableau. Okay, a Tableau is only a preliminary reduction that will be covered in this tutorial. And coming to Matplotlib, as I mentioned, it requires some sort of expertise on Python packages. So those who are interested to pursue their career in data science and data visualization, as I did some courses in data science and data visualization, so I believe that this introduction on Python packages would be definitely useful for those, for the aspirants of this data visualization going forward. So this is one quick when very brief information on what kind of packages of Python are useful for data visualization. So the libraries in Python, the library is usually a collection of functions and methods, okay, that will enable us to perform some lots of actions without explicitly writing the code for that particular action. Okay, and coming to the libraries in Python, in particularly to this data visualization, they are broadly categorized. We can broadly list like this. One is data scientific computing libraries are there. Data visualization methods are available, readily available in Python, and some libraries, algorithmic libraries also, we are in need of to do this practice. Coming to the scientific computing libraries, we should understand pandas, which helps us to understand these data structures. It offers data structures and tools for effective data manipulation and analysis. It provides fast access to the structured data, preferably. And the primary instrument of pandas is two-dimensional tables. As you know, most of you are familiar with the programming language like C, and in C there is one fundamental data structure which is array, okay, two-dimensional arrays, etc. So one can just recollect from that perspective to understand the pandas as a two-dimensional table, right? Then the primary instrument of pandas is two-dimensional table consisting of columns and rows, labels, which are called data frames. So this terminology will be frequently using going forward in order to, because I will be giving some demo by using my notebooks. So that notebooks will be shared after this lecture for further practice at your end. And I believe that because this is the prerequisite to understand this visualization part, so the prerequisite of this tutorial is some anybody should be familiar with some Python environment, right? And these pandas, NumPy and SciPy libraries will make our life easy in data visualization as well. Okay, and coming to the other libraries, data visualization, for that visualization we'll be using the libraries. The very popular one is Matplotlib. It helps us to get the plots, graphs, and which are more popular. So the more popular package for data visualization in Python. Okay, and we can also use Seaborn to write the graphics, okay, to produce the graphics, preferably in getting the heat maps, time series data. We'll be using this Seaborn, and I may not be able to cover this Seaborn. I will be giving you some examples and hands-on in Jupyter notebooks for you to for further practice using Matplotlib as well, Matplotlib alone. Okay, and algorithmic libraries, we need scikit-learn, wherein the popular machine learning algorithms are already available. Okay, the scikit-learn library contains tools for statistical modeling, including the regression, that is interesting, classification, clustering, and so on. Okay, and some stats models are also there, but I will not be using the stats models in my demo. So coming to the statistical charts, so after giving this Python libraries, because there is nothing to take it unless I mean just understanding what kind of libraries you require in order to do this data visualization. That is what the single point summary of these 3 to 4 slides so far, okay, on Python packages for data visualization. So we cannot understand entire pandas, numpy, scipy, scipy, matplotlib, seaborn, scikit-learn stats models, but from these slides one can understand that these are very much essential in order to do this effective data visualization. That's the single point summary one can conclude. And then moving on to the statistical charts, as I mentioned so far, that this is one example box plot. Sometime back in our demo, in our lecture, we have seen one example of such kind, and then a histogram. Okay, many more charts will come now. We need to get these charts because these charts will be meaningful if we produce by using some data. Okay, as this is data analytics, data visualization, we should have a data on hand to do this kind of plots, right? So to get this data, this is one example case study I am interested to share in this tutorial. This is not a new data which is available. This data is taken from University of Texas, which is published in this book, okay, written by Hammersch. The teaching rating, the data is about the ratings of teachers in the University of Texas. Okay, so there is some interesting analysis. So the analysis is on data to answer some questions like this. Do you think good-looking employees get high pay or faster promotions than the other ones? So it means the question is like, smart employees get higher pay than the others, or smart people, good-looking people get faster promotions than the others? That is what the question that was answered with some sort of analysis over on the data. And another question like, do you think good-looking instructors get higher teaching evaluations, etc.? So it is a survey, and the data is obtained from 463 courses. So we understood the background of the data and what purpose this data is being now considered for analysis. And to understand the data, the background information is not enough. We should also see the real metadata. The metadata is the data about data. It is giving us some very important information like how many rows are, how many records are there, how many rows are there, and how many columns are there. What do you mean by row and column here? Row means one example, right? And the column means by what values, by what variables the data is being captured, right? And now in this example, each row is for one employee, one faculty member, and columns maybe columns are representing the features with respect to which the variables with respect to which the values are being captured. So the details are as follows. There are variable types like including real numbers, some integer, continuous values are also there, categorical variables are there, and binary variables also there. Let us see one or two example variables which are listed here. So these are the variables which are available in our data, and the description of each variable is also given in the second column. For example, age of a professor, right? The age is the variable name, so it is collecting the ages of professors. And tenure, native, gender. So for example, gender is a binary variable, tenure is a binary variable, tenure yes or no, native yes or no. Factor variable, is the instructor a native English speaker, yes or no? It has two values. Okay, if the professor is native English speaker, native is yes, otherwise no. Gender, male or female, it has two values, it's a binary variable. Okay, and other, see the evaluation, it may be a number. What is the description? It is saying that Evaluation is the variable name. Course overall teaching evaluation score on a scale of 1 to 5, where 1 is very unsatisfactory and 5 stands for excellent. Okay, so it may be a rounded integer or it may be some fraction as well. Okay, preferably it is an integer variable in this case. So this is what the list of variables and the description of each variable given in this data, available in the data. So this is one quick descriptive statistics of the entire data. So descriptive statistics will give us very much information, very much important information, as I mentioned. It has, see, for example, the age. Age is one variable. It's a numeric variable. Okay, all these in this table, all the values, all the variables are numeric variables. Age, beauty, evaluation, students, all students. Students means the students register for a particular course. All students means all students, including all courses. Okay, so count is one information given. Mean, standard deviation, minimum 25, but that is the first quartile Q1 and Q2, and this is Q3, and this is max. Those are the 5-point summaries given along with count, mean, and standard deviation. So this shows how much data is available and how many numeric values are there, how many variables are numeric, and what are the important characteristics of these variables like count, mean, standard deviation, along with the 5-point summary. So in case of binary variables, example native, yes or no, so it is now given in terms of what count. Okay, how many native English speakers, native English professors are there, how many non-native professors are there. Okay, it's given in binary variables are given in terms of what, the counts, the frequency counts here, right? Then similarly, gender wise, tenure track, whether they are tenured yes or no, minority yes or no. Okay, now this is a simple histogram to understand the teaching evaluation distribution. Okay, so if you take teaching evaluation values ranging from 1 to 5 on x-axis, okay, each and every instructor is having one teaching evaluation score. So plot this all teaching evaluation scores. Okay, and the mean of all these teaching evaluation scores is, see, this is the teaching evaluation score. There are 463 totally. The evaluations are 463, and the mean is 3.99. The mean evaluation score is 3.998272, right? 998272 rounded to 83, and the standard deviation of this variable evaluation is 0.55, 0.55487, and the number of observations are 463. Okay, so this bar chart, if you see this bar chart, it represents the distribution of the variable evaluation. Okay, and from this one can see that the majority of evaluations are around the mean, mean is somewhere here, 3.998. so majority of the evaluations are falling near the mean with some standard deviation 0.55487. So this histograms, we can also do this. See, in the notebook, in the practical session, though it is not hands-on because it is one-way kind of thing. That means I am only the person who is using this Jupyter notebooks, and after this session only I will be able to give it to you, so that because the environment I am not familiar, how you are attending these sessions and whether you have the ability environment to run these Jupyter notebooks and all. So those things are not known to me, hence I'll be doing this, running my notebook to do this kind of graphic. So another visualization is possible that one can overlay one histogram over another histogram. For example, if I want to understand how the female distribution and how the male distribution and how they are related. So to understand this, the distribution, the histogram of male, we can do it over, and over that we can use the male distribution over female, the female ones. The frequent from this histograms overlaid for males and females, because we know this is categorization, and for males and as well as females. This one can understand something like this from this diagram, that these frequent lower teaching evaluations for females. So female have these frequent lower teaching evaluations for females is likely to influence the average teaching evaluation. So which gender has highest teaching evaluation scores from the graph? It is female. Okay, that is what the summary, that is what the inference one can get from this diagram. The average teaching score for male is higher than female, right? And this frequent, the reason is that reason may be that the frequent lower teaching evaluations for females is likely to influence the average. Okay, because all the time female are getting lower teaching score. This is the reason why we get the average teaching score of female also falls below these males. Okay, and moving on to another kind of graphic. Okay, as I mentioned, all these things we can produce because we have seen the data. Let us do some exercise also on this. I'll be taking to you that part in a couple of minutes. Before that, I'm trying to give you what is the meaning of each slide here, and before going to produce these graphics, right? So we understood what is this histogram and why it is useful, and what the inference we get from this, and putting one histogram over another histogram, and then drawing the box plot. So in the box plot graphic, so this box plot is rendered by taking gender on x-axis and age on y-axis. So as I mentioned, no need to repeat that box plot, what this horizontal line, this one, and so on, the minimum, first quartile, median, third quartile, and the maximum value. Okay, so in this graphic, we have created box plots for age variable. We can see that from this graphic, what is the inference that we can derive? The median of male is greater than the median of female. Median of male is greater than the median of female. So it is higher. Male's median is higher than female's median. And male's minimum and maximum age, they are also higher than the minimum and maximum values of female. Okay, so male's starting age, minimum age is also higher than the starting age of female. Male's maximum age is also higher than the maximum age of female. Male's median age is also greater than the median, higher than the median age of female. Okay, so this is what the inference I can provide at this moment. And we can also use box plots, not with one variable, with not with two variables. We can have three variables as well. So comparing age along with gender and the tenure variables. So age, now it is compared not only with gender as well as along with the tenure variable. So one color is given for female, and this color is given for light dark orange color is given for male. And now from this, what we can derive, what we can understand. See, the male, the tenure age of male is higher than the tenure age of female. Okay, so male tenured instructors are older than male untenured instructors. Male tenured instructors, this is the one. Male untenured instructors. Male tenured instructors are older than male untenured instructors, whereas female tenured instructors are much younger than female untenured instructors. This is the relation. So this kind of inference, this kind of conclusions we can derive from these small pictures. Then what is the percentage of males and what is the percentage of females in the entire population, that can be depicted by using pie charts. Now I would like to show you the visualization part. These notebooks will be given to the participants for further study, for further practice. Okay, create your own practice these Jupyter notebooks on your own machine. So those who are not familiar with Jupyter notebooks, you have to undergo some quick tutorial on what is Jupyter notebook and how it can be useful for effective teaching, as well as practicing the Python codes, right? And now, believing that most of the participants are familiar with Jupyter environment, I'm just running this Jupyter notebook. Okay, so Jupyter. Yes, this is the one notebook we are running. So before executing this, we need to what? Let me do it. Give me a second to get this one into my local host. Give me a couple of minutes, please. Keep. Give a couple of minutes. Okay, I need to go to this. Statistics for data visualization for Python, where the descriptive visualization. Yes. So my environment is getting ready. Okay. I hope now my screen is again shared. I have my Jupyter notebook here. It is for data visualization to understand. So loading the data is the first exercise we are doing. Before we load the data, we need to import all the required libraries, as I mentioned in the presentation, right? NumPy, Pandas, C1 is also imported here, and Matplotlib is imported here. I request everyone to focus because the font size is too small. I don't know how far it will reach if the participant is using mobile phone. Okay, and to run this Jupyter notebook, there is some button here to run the selected cells. So I'm selecting the cell to import all the required libraries. So the star indicates that the cell is running. Now it is executed. And now to read the CSV file, that means comma separated values file, because after importing the required Python libraries, we need to load the data. This is the Python code which will load the data from the cloud, right? The data is now available with IBM cloud, and now we are taking the data from that end, and it is a CSV file. So we are retrieving that, we are loading that CSV file, read that CSV file from that particular URL. So this is now run, and this is now completed, and now your data, that means your CSV file ratings data is available in readings_df data frame. Okay, then now we got successfully the data onto our board, and then let us see how many unique values are there. Okay, there are 69 columns. Sorry, there are 69 columns. Identify all the columns here. So there may be some duplicates of columns. After avoiding the duplicates here, we'll be getting 94 unique values, and age of all professors, here it is age, mean value of age variable is 48.33, and getting the standard deviation, and without this one individually, this is for our practice, but one can get the entire statistic summary, right, by avoiding the duplicates of all professors. Here without duplicates, the df.head here, no duplicates is the data frame as of now. After avoiding duplicates, head is head function will provide you the first 5 records of your data, and use the data to get the first 5 records of your data. Use this head command. Then these are the rows here. Okay, columns are minority, age, gender, grades, etc. And let us see the mean and standard deviation of age, and now ratings df. Now it is prepared. This you can ignore this as part of your pre-processing. Okay, for those who are not familiar with the very sound knowledge on Python, you can just consider this as your pre-processing. Just keep executing the commands, but you have to understand about this each cell. There is some description given what the cell is trying to do on the data. Okay, so that you please try to follow. Then this is the first graphic now we are going to produce, right? And this is the box plot, right? We are using white grid as our background, and we are trying to do this box plot as our first graphic, where on x-axis you have to take division, and y-axis we have to take evaluation score. Okay, and the data is now taken from the previous cell, that is division evaluation is the final data we have, right? That is the name of your data. Now if you run this, we will be getting the graphic as expected with white grid as background, x-axis as a division, right? Y-axis label is evaluation. So the values like division, lower values and upper values, this bar plot is now given, it is retrieved after evaluation, after running this cell. Okay, and then let us see the scatter plot. Okay, for example, if we want to try, because it is already run in the interest of time, that is why you are able to see the picture beforehand. Okay, but please try to see the command which is there in the cell, the particular cell above this particular graphic. Okay, we are now trying to use scatter plot, trying to get the scatter plot, okay, from this module, from this package, SNS package. Okay, and trying to take when label this x-axis with age, y-axis label is evaluation, and take the data frame ratings underscore df, and this is the, if you run this is how to run, and if you run this you will be getting the scatter plot. So this scatter plot depicts the relationship between age and evaluation variables. Okay, let us see furthermore. Give some different colors for both male and female. Okay, and this is how the scatter plot you can obtain, right? With gender, like taking gender, male with one color and female with one color, this can be achieved. Create this scatter plot with the scatter plot function in the Seaborn library. This is what SNS Seaborn library. This time we are adding here also we have used the Seaborn library, and here we are adding hue argument. Hue argument will provide us the coloring graphic, right, on gender, male with one color and female with another color. And how to get the box plots then? So here we are using Seaborn library again, sns.boxplot. Boxplot is the graphic name, right? To get this, we have to give this command sns.boxplot, and these are the arguments for this x, y labels and the data frame, right? Data is equal to the required the available data frame. Our data frame is ratings underscore df. So the plot is now, let us run this once again. Yes, now the graph is now generated, the graphic is available, box plot, and what more you can do is this one. Okay, cat plot. So what is the number of courses taught by each gender? How many courses taught by male, how many courses taught by female? This is also kind of bar chart, okay, giving you the count of male, female courses. Okay, and this is how to depict it, how to get this graphic. And let us generate the histogram, create a group histogram of courses taught by each gender and the tenure. Okay, gender, female and male, there are 3 attributes: gender, tenure and count. Here we are trying to see the number of courses taught by each gender, along with the details like how many males are there, how many females are there in the count. Okay, so this one can be achieved by adding another argument called hue. Hue on what? Tenure. Tenure should be given 2 different color for the 2 values of this variable tenure, and this is the we are using Seaborn library, and we are trying to produce the histogram. Okay, catplot is the module we have to use this, and the arguments are x, y, x label is gender, and the kind of, that means the y-axis label should be count, and hue is tenure. The data frame, the data frame name is given like ratings underscore df. So if you run this, we will be able to get this in the graphic. Okay. So I request the participants, in the interest of time, as I'm giving these notebooks to you, I believe you can do further exploration on this notebook given. This is the notebook prepared to practice this data visualization part. Okay, I'll be able to provide you, because it is now, I just practiced it during the course on data visualization, statistics for data visualization. The very good notebook with a lot of information. And further, to get this descriptive statistics, okay, as I mentioned in the slides, that the first step is import all the required libraries, get the data from the URL. The data description is like this: what kind of variables and what is the description, and this part is again taken to our slide and explained there. And so the structure, that display information about the data set. Let us see what is the structure of the data frame, description of the data set. This is the structure of the data frame into rows and columns, description of the data set, number of rows and number of columns. So print out the first 5 rows of the data. It can be done using this command. This ratings underscore df is the data frame name. Use the head function to get the first 5 rows of your data, and then to get the information, that means how many entries are there in the total data frame. That means 0 to 4. This info is the function you can use to get this information of the entire data frame, right? So this information is telling us about 463 entries are there in the entire data frame. They are numbered like 0 to 462, and the number of columns, there are totally 19 columns. Okay, a total 19 columns are there. Each column title is given on the top of the column. Okay, there are such 19 columns are available, and the column names are like this. Okay, whether they have full count or not. Okay, the data type of each one, the data type is like minority, that means the data type is object. So in this context, integers are there. So gender, object means there may be binary variables here, right? And float values, beauty takes integer real numbers. Beauty is the variable taking float values. So the data types of each variable also observed can also be observed in this summary, in this information. Okay, and what is that? How much memory is utilized to load this data, to store this data is also there. Okay, there are 2 float variables, there are 11 integer variables, and there are 6 binary kind of variables, and total memory used is this much. And if you want to shape, because array you can just observe in terms of rows and columns. To get the number of rows and number of columns, use the command called ratings data frame name dot the shape, right? Shape, if you provide that and run this, you will be able to get 463 rows and 19 columns, as I mentioned. 463 rows, 19 columns. And now get the first 10 rows, okay, just for our understanding. And taking the mean, median, minimum and maximum values for students row, students column, right? This is the table with 10 rows here. Now take one variable, that means students column, take its mean, median, find its minimum value, find maximum value, and let us all produce all these things in one shot, that is by using describe function. Okay, to get this descriptive statistics table, we have to use the command give the data frame name dot. Okay, and then use this describe function. It will be, you will be able to see the count, mean. This part is again taken to your slide and explained there. So this is how to get this descriptive statistics table. Okay, this is the command. And now get the histogram. As I mentioned, to get the histogram there are many ways. We are using now PyPlot to get this histogram, and then gender wise, because the gender is a binary variable. Okay, take the gender, group by gender like male and female, group by age, that means beauty age, then get the index values, get the mean, get the summary, right? Zero male with mean standard deviation, and male with this mean standard deviation and variance, right? So calculate the percentage of males and females that are tenured professors, okay, with different genders. This is the one. Finding the number of males, number of females, and their average, their percentage, including the tenure as well as gender, right? Percentage of male and female tenured. This is the percentage. How to get this? This is the command. So, and these are the other questions for you for your testing of your understanding going forward. So actually, I'm interested to explain this more, but I am scared, because if the prerequisite, that is the knowledge on Python, is not so good, then it is like a Greek and Latin to understand this visualization part. Okay, but I still believe in a positive way that provided these notebooks shared to participants, they can run this at your convenient time to understand in a much better way. Okay, now I am coming back to my presentation. Okay, and now before giving these notebooks to you, another set of notebooks also I'm interested to share, which are to understand the line plots, area plots. Okay, line plots and area plots on some other data, that is the immigration data to Canada. Okay, so for your case study 2, so this data or teachers rating data, on this data you can do this practice, like getting the 5-point summary, okay, getting this frequency counts, and produce these histograms, box plots, and pie chart, and the respective relevant notebooks are now briefly explained, run through, and that will be given to you for your practice. And the second data set which I am interested to share is the immigration to Canada data. The population details, who are immigrants to Canada from various parts of the globe, from, let us say, there are 45 countries information given in this Excel sheet. So if it is in the full screen mode, you can just see row number 22 here in this Excel sheet. Okay, class, type of class, immigrants from foreign countries, origin is Afghanistan, major area is Asia, okay, region name South Asia, it is a developing region, right? And in 1980, how many immigrants are there from Afghanistan? 1981, 1982, there are 39, 1984, there are 71, etc. So like this, from each country, annual data on the flows of the international migrants is reported in addition to other metadata, right? Like how many, that metadata will be known to you in a couple of minutes. So this is used for our case study on immigration to Canada, and this is the line plot, which you can again plot in your practice using the notebooks provided to you at your convenient time. You can do this line plot. So this line plot taking this data, immigration data to Canada, and it is to understand how many immigrants are there from a particular part of the globe, that is Haiti, and plotting this by taking number of years, number of immigrants on y-axis, number of years on x-axis. We are trying to draw the line plot here, and from this line plot there is some sudden increase in the number of immigrants somewhere in the year 2010. There may be some big reason why the number of immigrants are rapidly increased in particular year 2010. So a line plot is a type of plot which displays information as a series of data points called markers connected by straight line like this, and this is how this is an example line plot which is again can be practiced in your using your Jupyter notebooks. And then as I mentioned, area plots one over the other commonly used to represent cumulated totals using number or percentages over time. So in the introductory talk to understand various plots, we looked at area plot as well. So area plot is useful to depict the cumulative totals using let's say some percentages over time. So this is very good data, immigration data, where on x-axis we have the years, and the y-axis now here we have number of immigrants over the years. And apart from line chart depicts only one variable here. If you want to analyze the number of immigrants over the time from, let us say, 1980 to 2015, and from different parts of the globe, different countries, this is the area chart giving you the totals, right? For example, in 1980, more than 40% immigrants are there from Pakistan, okay, and from Philippines it is lesser in number. In 1980, somewhere around 40,000 immigrants are there from Philippines. Similarly, from India, the immigrants are less, okay, over the years when compared to other countries. And so on the same data, we can also use bar charts to understand the histogram. Histogram we can produce, and as well as from histogram one can produce bar charts as well. So unlike histograms, this bar chart is used to compare the values of variables at given point of time. For example, in 1981, number of immigrants from one part like Iceland, immigrants to Canada from 1980 to 2013. So from one part of the globe to Canada, how many immigrants are there over a period? Okay, only from one part. So this is the histogram which explains this distribution of the data of immigrants from one particular region of the globe in a given period of time, that is 1980 to 2013. Okay, so this demo 2 will help you to do this plotting. Okay, now this is I am running in my local host. Okay, and this is the data, United Nations immigration data. Excel sheet is available, and if you want to see the Excel sheet, this is the data how it looks like. This is the data how it looks like. Okay, provided by United Nations. Okay, immigrants from different parts of the globe over a period. Okay, this is a huge Excel file. Okay, and how many immigrants are there, how many rows are there, how many columns are there, you can see. Okay, sometimes the information is absent. Okay, so this is, but we need to do this data avoiding some zeros here. Sometimes it is zeros, sometimes it may be some missing values. So this data also to be purified, which is to be done before doing this kind of plotting, etc. Okay, and this notebook I'm sharing to the organizers to share it along with you. Okay, to get the head and tail. Head means the first 5 rows, first 10 rows. By default it gives 5 rows. Okay, and by default it gives the last 5 rows if you use the tail function of your entire data. And the data frame, okay, is having number of rows and columns. You can see the index values. That means what is, you can get the 5-point summary as well, the type of each column. Okay, and the shape, now it has what, 195 rows and 43 columns in your data frame. Okay, by 195 rows and 43 columns. Let us have the information on, if you want to get some information on particular columns like area. Okay, this is how to get it, some portion of your data. And this is the 5-point summary, descriptive statistics you can get by using the command dataframe.describe. Okay, and then you can do further exploration here. How many immigrants are there from India? And last one is getting this line plot. Okay, from Haiti area, from Haiti, using the data frame, from Haiti over a period. Okay, I need to run all. So to run all, without running, we cannot run all cells. Okay, there is some problem, small issue to run all the cells quickly, but this is already run, is already executed. The Haiti plot. This is the plot I have shown you during the presentation, and this is the set of, this is the patch of code to get this line chart, and this is how you can demark the peak at a particular instance, right? Using the running text like 2010 earthquake. So there is in the data it is said that because of some earthquake in 2010, a lot more immigrants are there from Haiti to Canada because of this calamity, right? And so these are the line plots on India. This is the line plot to understand the immigrants population from India as well as China, and to get this line plot from 5 different countries. Maybe in the next set of exercises, you will be able to get this area plots as well. This is the line plot at this moment from the 5 different countries, how the immigrant population is increasing and decreasing over a period of time. Okay, and the other plots are there given for your practice. And this Jupyter notebook will be helpful for you to understand further how to get this. As I mentioned, it is not so easy to demonstrate each and every line of this patch of code, but this is to be practiced. Without background knowledge of Python may be difficult, obviously, but by doing some sort of study and practice, you can get some expertise on that. And as I mentioned, it is already run. In the interest of time, getting this 5 data pre-processing, it is already done. Now just have a quick look at the area plots. As mentioned, this is the area plot showing the immigration population from 5 different countries over a period of time from 1980 to 2015, etc. 2015 or so. Okay, this is how the plot can be generated using this patch of code. Please try to run this once again. Let me run this once again. Yes, it is working. This is just now executed in the interest of time, and you can also play with colors, okay, etc. And this is the line. This is the area curve that we have seen in the presentation. Immigration trend, to analyze the immigration trend from top 5 countries over a period, from top 5 countries like India, China, UK, Philippines, and Pakistan. See, the number of immigrants from Pakistan is more every year. Okay, whereas the immigrants from our nation, India, it is less. So, as I mentioned, this picture speaks a lot. Okay, and further you can practice the box plots because these are not executed intentionally for you to practice, and various other pie charts that are left over here. This is how to get the pie chart as a patch of code. Use this notebook to do further practice, and different styles of pie charts, highlighting the immigration data to Canada from different countries, like different regions like Africa, Asia, Europe, right? Different continents, and this is you playing with different colors, and this part of the notebook will help you to get the box plots, okay, and box plots of immigrants from China and Canada during the period 1980 to 2013. If you see that the median is same between both in India as well as China, the number of immigrants migrated, from these two regions, from these two countries. But the maximum value and the Indians are less. Okay, you see that maximum value. Okay, so Indians are less immigrations from India from when compared to China. Okay, and this is the quartile box plot. You can get this box plot using this patch of code which is provided here, and then you can just rotate the orientation of your box plots, and then you can also put all sub plots in one figure, because usually while writing the paper, this is the way how you may be interested to produce your graphics. Okay, so this can be achieved using this part of exercise. So that is what I would like to convey. As I mentioned, this cannot be we cannot completely explain this, make you proficient in visualization in half an hour or so. Okay, and I hope that you can take this as your introductory tutorial, and do some little more practice on this. And towards the end, quickly, just I'd like to just introduce what is the Tableau for data visualization. And so during because I am also subscribing this Tableau to do this data analytics, I am trying to produce some a platform for COVID-19 data analytics. As part of that, I am working on this Tableau. As per the information available on Tableau, the most popular one is the for data business analytics is Tableau, and leading companies like LinkedIn, Cisco, Walmart, TripAdvisor are using Tableau for their business analytics, and it is easy tool. When because it is like a drag and drop kind of activities are there. No need to worry about understanding what kind of plots are useful for what kind of data. So it is easy to get that information using the very easy, friendly environment on Tableau. And there are two versions actually. The paid version is there. If you want to get a paid version, you have to use Tableau desktop, wherein you will be getting unlimited rows of data can be accessed, and you can also get the data from all data sources publicly available. You can save the analysis and in your local system. But if you don't want to purchase it, then there is a free version available, which is Tableau Public. Okay, you can save your reports, your worksheets online. Okay, you can, but there is a limit to access the type of the data. That is only CSV files you can get access, and Excel only text files. These are the three types of files you can access, and 15 million rows of data only you can use in your analysis and visualization. But there is a free option available for student community for one year, and for instructors also. Tableau is providing free access upon your request for maximum of 1 year. We are using Tableau desktop version, and we are accessing Tableau for teaching and analysis purpose. And this is the Tableau interface. I'd like to just quickly play a short this one video which I have prepared just as an introduction. Go to Drive. This is not a complete one, but it will give you a kind of very quick look. There are two icons of Tableau you can observe here. One is the desktop version, another one is the public version. Public version is free, as I mentioned. So this is the one I am trying to open, the public version. Okay. Sorry, meanwhile the desktop is also there. I'll try to record one more very good video without this conflict. So once you get this public Tableau version installed on your machine, you should download some data as well as worksheets. So this is an example data. This is one example data of San Francisco. This is the data of automobile industry. Sorry, this is the data of what? Yeah, this is the data of Airbnb. It is regarding the areas, neighborhoods. Let me close that. It will be closed. Yes. Yeah. This is the data of San Francisco regarding the rentals provided by Airbnb. This is the data which is used to analyze by Airbnb to improve their profits. So the study is about in which neighborhood, what is the location of each neighborhood. For example, neighborhood is Mission, row number 8. This is the data. Okay, you have loaded the data. To load the data, so click on. I'll be able to demonstrate right away. Okay, I hope you are all able to see the screen. It will take. Yeah, this is the Tableau public version. Once it is open, get your data. Open. I am now opening what? It is already there. Data is already available on my desktop. Okay, and the data is now loaded. Neighborhood is one column. See, you can see different colors. This symbol is saying that the variable is representing some location values, geographic location values, and this is numeric data. If it is with this symbol, hash symbol, it is numeric data, and these are the columns of this table. San Francisco is the name of that CSV, and there you can see in the 8th row highlighted just now, like in each neighborhood, what is the location values, what is the price of that room available, property available for rent or for some hiring purpose. Okay, number of days occupied, this is the previous history, minimum nights used, minimum number of what is that, reviews available. Okay, reviews for each month, availability of the room of the property for rental or share purpose in year 2019, etc. So these are many, there are many things. So if you want to see the working environment, so this is the view of your worksheet. Yeah, Tableau environment. So here you can see show me button, which you can just click on. It will drop the types of graphics available you can produce. So as we have already taken San Francisco data for our analysis, so if you want to analyze this, let us take the neighborhood on x-axis. So these are the neighborhoods, and price. Let us see number of reviews with respect to number of reviews. So if you just undo this, if you use this button, it will undo whatever you did. Price, I want to get the price values. Okay, see, the graphic, if you get, let us say, yeah, I have discarded this price. If you get price, select the price variable. Once you get this, it will automatically highlight the locations where you can put this. If I put this in text, then it will, this is the summary you get. Okay, in each neighborhood, what is the price? Now if you want to display this using now if you just click on show me, then it will identify, it will highlight the, it will highlight the possible graphic you can produce. So it is only an indication, but you can, and you can play with all graphics of your own interest. But right now it is suggesting us, it is, bar plot is suitable for this representation. So this is the bar plot, and uh, price values are labeled here. Yes, if you just, if you want to put the price values on top of each bar, then this is how you can show that. So this is only an introduction, just to make you confident and familiar with the environment. I believe that this may not be enough to get the proper introduction of Tableau, but I try to provide some information about Tableau. Further, you can practice using the video lectures available freely, and YouTube tutorials are also available on Tableau. And Edureka is providing a lot of video content on Tableau practice, and you can also use DataCamp to get some proper introduction on Tableau, how to play with that. And this is only one graphic we produced, and see the room types also, if you consider, right? And let us produce this different graphic. Like, it is very quick and very quick, without worrying about this Python coding, etc. But it needs some sort of practice. So whichever environment is good for you, then you can take it from there on, right? This is the graphic we produced. This is the plot, stacked bar chart. Okay, and room type is the one with different colors, right? Room type is the one we used to differentiate. This one is what? Mission, neighborhood. Room type is apartment or entire home kind of thing. This is the private room. Okay, somewhere it is red color is also there. Let us see that. What is the red color? Red color says room type is shared room. Okay, so number of, in this region, neighborhood, mission is the neighborhood. Home apartments are preferred by many people, and the price of home apartment is high when compared to private rooms, and this shared rooms are nowhere available in this particular region. Okay, mission. So this is how we can get some inference from these different kinds of plots. You can also produce some things like how many number of reviews. So if you just take this out, then automatically it will be removed. Okay, all variables are now removed. Just reviews per month. Okay, only neighborhood. Take this neighborhood here. Okay, and respect to price. Okay, this is the, we have selected this one. Room type. Okay, see what is this now? Here, this part is, we just generated a pie chart. This is a private room portion, and this is entire apartment. in a region called Downtown Civic Center, in the neighborhood, private rooms portion is less than entire home apartment categories. Okay, this is how one can just take the help of available graphics. Just click on this show me. It will highlight a graphic for your data and selection of variables for your this one is also very easy. Just drag and drop here. For further complete understanding, I advise to go for some tutorials and courses on how to use Tableau. So with this, I tried my best, I believe, to provide some sort of preliminary information on data visualization using these two environments, Python using Python, that is using Matplotlib, and towards the end, I also tried to give you a very small introduction on Tableau. So with this, I'd like to thank the organizers once again and thanks the participants for patient listening to share the content. And I should acknowledge the Coursera and Harvard University team for providing the data for teaching purpose, right? With this, I'm done. Now over to organizers.
Participants, if you have any queries. So if no queries, I'd like to thank Hitendra Sharma sir for taking his valuable time and being with us. Really, it was a very exhaustive session that you have given where you have explained us neatly the data visualization topic, how it has to be done in using Python as well as Tableau. It really benefits all the faculty members who are pursuing their research. Thank you very much, sir. It's really a informative and a valuable session for all. Thank you very much, sir.
Thank you, madam. I'll be sharing that Python Jupyter notebooks as well as some information on Tableau also, tutorial on Tableau for further study. Thank you.
Yes, sir. We'll distribute it to all the participants. Yes.
Yes. So if you can
sir?
be, no, I'm just requesting the participants further collaborations on data visualization if it is possible, because as I mentioned, I'm interested to do this COVID-19 data analytics. Okay, because now COVID-19 data is available publicly. Some reliable sources are there. Tableau is also supporting us to do that. So if anybody interested, we can also do in groups. That is what my invitation. Thank you.
So thank you very much, sir. Participants will break for lunch and we'll be starting the next session by 2:30.